Have you ever wondered how robots work? How they move, sense their surroundings, and perform tasks? In this video, we'll show you how to build your own robot from scratch. Before we begin, let's go over the basic components you'll need to build a robot. First, you'll need a microcontroller, which is the brain of the robot. This is where you'll program the robot's behavior and control its movements. Next, you'll need motors to provide movement. These can be DC motors, stepper motors, or servo motors, depending on the type of movement you want your robot to have. You'll also need sensors to detect the environment around the robot. These can include infrared sensors, ultrasonic sensors, or cameras. Finally, you'll need a power source such as batteries or power supply to provide energy to the robot. With these basic components, you can build a wide variety of robots, from simple line-following robots to complex humanoid robots. In the next segment, we'll go over how to choose the right components for your robot. Now that you know the basic components you'll need to build a robot, let's go over how to choose the right ones for your project. First, consider the purpose of your robot. What tasks do you want it to perform? Does it need to move around, sense its environment, or interact with objects? Next, sketch out a rough design of your robot and determine how many motors and sensors you'll need. This will help you choose the right microcontroller board, as some boards have a limited number of pins for connecting components. When choosing motors, consider the torque and speed requirements for your robot. DC motors are good for simple movements, while stepper motors are better for precise movements. Servo motors are ideal for robotic arms and grippers. For sensors, consider the range and accuracy you'll need. Infrared sensors are good for detecting obstacles, while ultrasonic sensors are better for measuring distance. Cameras are ideal for object recognition and tracking. Finally, choose a power source that can provide enough voltage and current for your robot. Consider the size and weight of the battery, as well as its capacity and charging time. With the right components, you can build a robot that meets your specific needs and performs the tasks you want it to. In the next segment, we'll go over how to assemble your robot. Now that you've chosen the right components for your robot, it's time to assemble them. First, lay out all of your components on a table and organize them by type. This will make it easier to connect them to the microcontroller board. Next, connect the wires from each component to the appropriate pins on the microcontroller board. Be sure to follow the wiring diagram for your specific board and double-check your connections before powering on the robot. Once your components are connected, test the robot's movements and sensors to make sure everything is working properly. You may need to adjust the code on the microcontroller board to fine-tune the robot's behavior. Finally, add any finishing touches to your robot, such as a body or casing, to protect the components. You can use 3D printing or other fabrication techniques to create a custom design for your robot. With your robot assembled, you can now program it to perform a wide variety of tasks. In the next segment, we'll go over how to program your robot using a programming language like Python or C++. Now that your robot is assembled, it's time to program it. First, choose a programming language that is compatible with your microcontroller board. Popular languages for robotics include Python, C++, and Arduino. Next, write code that controls the robot's movements and sensors. This may involve using libraries or API for specific components, such as motor drivers or sensor modules. Once your code is written, test the robot's behavior and make any necessary adjustments. You may need to tweak the code to fine-tune the robot's movements or add additional functionality. You can also add additional features to your robot, such as voice control or remote control via a smartphone app. This will require additional programming and may involve using wireless communication modules like Bluetooth or Wi-Fi. With your robot programmed, you can now use it to perform a wide variety of tasks, from simple movements to complex interactions with its environment. In the final segment, we'll go over some tips for troubleshooting common issues with your robot. Even with careful planning and assembly, you may encounter issues with your robot. Here are some tips for troubleshooting common problems. First, check all of your connections to make sure they are secure and properly wired. Loose connections can cause erratic behavior or prevent the robot from functioning at all. Next, check your power source to make sure it is providing enough voltage and current for your robot. Low voltage or current can cause the robot to move slowly or not at all. If your robot is not behaving as expected, check your code for errors. Syntax errors or logical errors can cause the robot to behave unpredictably or not at all. If you're still having trouble, consult online resources or forums for help. Other robotics enthusiasts may have encountered similar issues and can offer advice or solutions. With persistence and troubleshooting, you can overcome any issues with your robot and continue to improve its performance and capabilities. Congratulations on building your own robot. With the right components, assembly, programming, and troubleshooting, you can create a robot that meets your specific needs and performs the tasks you want it to. Thanks for watching.